we are going to be unraveling a literal 175-year-old cosmic detective story today, one that completely shifted our entire understanding of the universe. I'm so thrilled to guide you through this because it's a tale packed with mystery, invisible forces, and a discovery that honestly borders on the unbelievable. So let's break down exactly how human ingenuity solved one of the absolute biggest mysteries in the night sky. So let's just kick things off with a massive, kind of impossible sounding question. How in the world was a planet discovered without a telescope? I mean, we're talking about an era when humanity's primary way of understanding the cosmos was by, staring through curved glass and freezing dark observatories. Yet the feat we're looking at today completely bypassed traditional astronomy and absolutely stunned the scientific community 175 years ago. Well, the answer is deceptively simple, with just a pen and some paper. Pure math cracked this interstellar case, not glass lenses. But to really understand how something like that is even possible, we have to rewind a bit to one of the most famous moments in all of science history. Yep, Sir Isaac Newton and that legendary falling apple. Right, so when Newton watched that apple fall, he formulated the universal law of gravitation. And the rule is elegantly simple. Any two objects in space attract each other, with the larger mass always pulling the smaller one. It's the exact same reason the incredibly massive sun pulls our planets into an organized orbit, or why our smaller moon pulls Earth's ocean waves. Basically, the whole universe is tied together by this giant, invisible gravitational tug-of-war. But that brings up a good point. If gravity is constantly pulling things together, why doesn't everything just crash right into the sun? The answer is centrifugal force. As a planet moves in its continuous circular orbit, it generates an outward push. It's a perfect cosmic balancing act, really. Centrifugal force precisely balances out gravity to keep orbiting bodies safely apart. And for decades, astronomers believed these were the absolute, unbreakable rules governing our universe. Okay, so fast forward a bit. By the year 1781, the planet Uranus was discovered, which officially became the new edge of our solar system. But by the 1840s, astronomers started noticing this really strange anomaly, a weird orbital wobble. Uranus was seemingly defying Newton's unbreakable laws. At specific points in its orbit, it would just drift off its expected mathematical path. And for 60 years, the absolute best astronomers in the world were completely baffled by this. Enter French astronomer Urbain Le Verrier. He decided to look at the problem a little differently, and he asked a pretty radical question. Is there a massive, unseen planet tugging at Uranus? Le Verrier theorized that Newton's laws weren't actually broken at all. Instead, there had to be a hidden, massive suspect out there in the dark, exerting its own gravitational pull and literally yanking Uranus off its path. As you can imagine, this created a huge divide in astronomy. For decades, traditional stargazers were out there staring blindly through their telescopes night after freezing night, trying to solve the mystery just by looking harder. They largely rejected Le Verrier's whole mathematical theory. But on the night of September 23, 1846, Le Verrier ignored the telescopes entirely. He just sat at his desk and meticulously calculated the anomaly using complex math to track down this invisible suspect. And he didn't just take a wild guess. Le Verrier mathematically calculated the exact mass and the pinpoint location of this theoretical object. He was so confident that he mailed his coordinates straight to the Berlin Observatory. When Dr. Johann Gottfried Galle received that letter, despite all the skepticism of the era, he aimed his telescope at that exact tiny patch of the night sky. And guess what? Almost immediately, a faint blue planet was found right where the math dictated it would be. Just an absolute triumph of the human mind. To really wrap your head around the sheer physical scale of what Le Verrier found using just a pen, if Earth were the size of a standard tennis ball, this newly discovered world, Neptune, would be the size of a basketball. You could literally fit 4 entire Earths inside it. He had mathematically weighed and located this colossal giant floating out in deep space without ever actually laying eyes on it. But history is full of wild ironies. Get this, Galileo Galilei actually saw this exact planet through his early telescope over 2 centuries prior. But because it moved so slowly across the sky, he just recorded it as a background star, completely missing the discovery of a lifetime. Meanwhile, Le Verrier never physically saw the planet during his research, yet he proved it was a planet, securing all the historical credit. So,
With the eighth planet finally confirmed, a whole new debate erupted over what we should actually name the thing. Leverrier, naturally, wanted his own name attached to his brilliant discovery, but the broader scientific community pushed back on that. Following the long-standing tradition of using mythological deities, they ultimately settled on the Roman god of the sea, Neptune, which really is a perfect match for the planet's stunning, deep blue appearance.
Now, for over a century, Neptune remained just this tiny, mysterious blue dot in even our very best telescopes. But that completely changed in 1989 when NASA's Voyager 2 spacecraft made its historic flyby. Skimming just 3,000 miles above its cloud tops, Voyager 2 finally gave humanity a high-definition look at this mathematical marvel, and it revealed a dynamic, chaotic, and honestly incredibly hostile world. The sheer scale of Neptune's orbit is just vast. It sits 30 astronomical units away from the Sun. To put that into perspective, that means it's 30 times further from the Sun than we are here on Earth. It is the most remote planet in our solar system, just suspended way out there in the lonely depths of deep space. And because of that massive distance from the Sun's warmth, the surface temperatures on Neptune just plummet to negative 210 degrees Celsius. NASA literally categorizes Neptune as an ice giant. It is a profoundly freezing world, permanently locked in a deep freeze that's almost incomprehensible to us. But as you'll see, cold certainly does not mean quiet. Unending, super violent winds roar across Neptune's surface at roughly 2,000 kilometers per hour. Think about that for a second. The maximum storm wind speed ever recorded on Earth was just 407 kilometers per hour. So Neptune's massive storms are incredibly fierce and chaotic compared to even our absolute worst weather. When we directly compare our home to this distant ice giant, the differences in time and space are pretty mind-bending. While we sit comfortably at 1 AU from the Sun, Neptune is way out in the dark at 30 AU. Interestingly, Neptune actually spins incredibly fast, completing a full day in just 16 hours compared to our 24. But here's the real kicker. One full orbit around the Sun takes Neptune 165 Earth years. That means, since its discovery way back in 1846, Neptune has completed barely a single year in its orbit. Crazy, right? Today, the story of this incredible discovery is quite literally carved in stone in Paris. At Urbain Le Verrier's tomb, a physical model of Neptune sits proudly, forever honoring what he pulled off. The man who expanded the known boundaries of our solar system using nothing but paper, logic, and his own intellect is immortalized right alongside the very world he found hiding in the dark. Which leaves us with a genuinely fascinating thought to ponder. If pure math can find an invisible, massive planet floating in the pitch black of deep space, what else is hiding out there in the vast universe just waiting to be calculated?